This is my second video in my series about shadow casting, and you can find the rest on my other YouTube site listed here. And check out my book on Amazon. The Kindle is only $5. The basics of shadow casting is this light triangle that gives us the relationship between the light source, the pole, and the ground. And to do that, we need a vertical line, connecting the light source to what we call the shadow vanishing point. And the shadow vanishing point goes through the bottom of the pole, while the light goes through the top of the pole, and they meet at the end of the shadow. To connect the light source to the casting surface, we need the vanishing point for the shadows to be on that casting surface. And the light and this vanishing point always have a vertical relationship with each other. If the light ray is nearly horizontal, then we get a long shadow, which is typical of sunset. If instead it's more vertical, then we get a short shadow, which is typical of noontime. If the pole is in the air, then the light is tangent to both the top and the bottom of the pole, and where they meet the shadow line defines the length of the shadow. In this picture, I made one of the columns the pole and found the end of the shadow. And when you connect that end of the shadow to the top of the pole, you get the light direction. In this situation, the shadow direction is horizontal, so the angle it makes with the vertical is a 90-degree angle. Most of the time, the shadow direction isn't horizontal. Two examples are backlighting here, where the sun is behind the object, so we see the shaded part of the object, and the shadows come toward us. The other situation is front lighting, where the sun is behind us, so it hits the front of the pole, making it light, and the shadows go away from us. When we don't look at the sun, then the light rays and shadows are parallel. In this example, I connected the ladder to its shadow on the ground, and that gave us a light direction going up this way. The light rays are parallel, and the shadows are either parallel or converging. In contrast, sun rays radiate out when we look at the sun. In this situation, you can see that there's radiation of the shadows, and these shadows converge toward a shadow vanishing point on eye level, which is also on the horizon. And directly above that is the light source, where sunlight hits the top of the pole to reach the end of each shadow. Here are two examples of parallel rays, sun rays. And we know they're parallel in this case because the shadows are parallel. In this image, the sun is over here, so we're looking toward the horizon, not at the sun. Another scenario is at sunset, and unlike the previous sunset picture, these shadows are fairly parallel. And that's because the sun is in the distance to the right, and we're looking down, so we're not looking at the sun. So whether the sun rays are radial or parallel depends on our viewpoint relative to the sun, whether we're looking at it or not the time of day. With parallel sun, the proportion of the height of the pole to the length of its shadow remains constant. So let's look at this pole, and let's say it's like 1x, and let's say this is 1.5x. Well, then if you go to this distant one, this is still 1x and 1.5x. The same principle applies in front lighting. That is, if we're looking at the sun, or the pseudo-sun, the shadows radiate out. So let's try to understand this picture. The sun is behind us, coming in this direction. If we connect all the shadows together, we find that the shadow vanishing point is here, which is on eye level or the horizon. The pseudo-sun lies on the shadow of the viewer's head. So this is the viewer's head, and the pseudo-sun must be vertically below the vanishing point for the shadows. This is an example of front lighting with parallel shadows because we're not looking at the pseudo-sun. So the light is behind our left shoulder, going down like this to the pseudo-sun, while the shadow vanishing point goes up toward the horizon. And you can see that these shadows of the bike are relatively parallel because we're not looking at the pseudo-sun. The other situation where we have radial light is when the source is artificial, like a lamp. And here we have the light source. And this time, instead of being on eye level, the vanishing point is on the ground, and it's usually not on eye level. I put several vertical poles around this light source, and you can see that the light comes down and hits the top of them, and the shadow line goes through the bottom of them. And as a result, the shadows are different orientations, different lengths, etc. This is an example of artificial light. Let's make this man a pole and then find his shadow. The light is a large light source, and it sends light rays across his head to the wall. Meanwhile, the vanishing point for the shadows is on the ground, vertically underneath the light, and it goes under his feet to the wall, and that gives us the shadow. Let's go through some examples. The light source in this case is the orange dot, the vanishing point is the blue dot, and the red vertical pole is right here. This must be sunlight outside because the vanishing point is on eye level. So we draw light rays down hitting the top of the pole and shadow lines going through the bottom of the pole, and the end of the shadow is here, and this part would be the shadow. So this is side lighting because it's hitting the side of the pole. In the next one, again, it's outside because the vanishing point is on eye level, and it goes through the shadow goes through the base of the pole. The light direction goes through the top of the pole. Whoops. And so then this whole area is the shadow, and this is backlighting because it hits the back of the pole. In this next case, again, we have the vanishing point on the horizon, so this pole must be in the air. And as a result, it has two floating ends, those that are not attached to the surface. So the light goes through both of these ends. And in this case, I'll just choose a shadow direction like here. So then the shadow goes from this point to this point. And then the last one is artificial light because the vanishing point is on the ground, and it goes through the base of both of these poles, and the light goes through the top so we can find these shadows. This video shows three types of lighting. There's radiating lighting when we're looking at the sun or the pseudo-sun with the vanishing point on the horizon or eye level and the sun above it. And you can see the shadows go to the vanishing point and the light rays go to the light. Another situation is parallel sunlight with no visible vanishing point for the light or the shadows. And you can see that the light is parallel and the shadows are also relatively parallel, or at least converging toward the same vanishing point. And then the final one is artificial radiating light, where the vanishing point for the shadows is now on the ground, not on eye level. And we expect eye level to be about here as we're looking down at the table. Here's a summary of this video where I compare radiating light, parallel sunlight, and radiating artificial light.